Hello students, welcome to Sri Vardhaman Vidyalaya online education. So today we will see the part 4 of chapter 3, metals and non-metals. So in this part we will discuss about the metal reacts with water. So first we will see the activity, what happens when metal reacts with water. So in your book, that is activity 3.10. Collect the sample of the metal, aluminium, copper, iron, lead, magnesium, zinc and sodium. Put the small pieces of the sample separately in beaker, half filled with cold water. Which metal reacted with cold water? Arrange them in increasing order of their reactivity with cold water. Did any metal produce fire on water? Does any metal start floating after some time? Put the metal that did not react with cold water in the beaker half filled with hot water. For the metal that did not react with hot water, arrange the apparatus as shown in the figure 3.3. Observe their reactions with stream. Which metal did not react even with a stream? Arrange the metal in the decreasing order of reactivity with water. So in this activity, we are taking in a sample of a metal like aluminium, copper, iron, lead, magnesium, zinc and sodium. So put the small pieces of sample in a beaker containing cold water. So you have to see that the metal reacts with a cold water, then you have to arrange in the increasing order of their reactivity with cold water. And you have to check whether the metal will produce a fire on water. Or after some time you can check this also, that is a metal can float after some time. Here some of the metal will not react with the cold water, so then you have to again add this metal that reacts with hot water, and you have to repeat the same experiment, and you have to then check with a stream. So then also you have to check whether the metal do not react even with a stream. Then you have to arrange the metal in the decreasing order of their reactivity. So here we can see the apparatus. So this is the apparatus, that is an action of a stream on a metal. How we can see the metal? Okay, so here you can see the metal sample, and this is in a glass or in a wool soaked in the water. Then you have to heat. So when this will be heat, what happens? The heat will be transferred to the metal. And here that is delivery tube, and here you can see that is in a water bath. So what happens? That is in a metal will be displaced. So when metal reacts with a water, so it will form a hydrogen gas. So the metal reacts with the water, produce a metal oxide and hydrogen gas. So the metal oxide that are soluble in water dissolve in it to further to form a metal hydroxide. So the metal that will be soluble in the water, so it will form a metal hydroxide. But all the metal do not react with the water. So this is the apparatus of the action of steam on the metal. And here the metals that will do not react, all the metal do not react with the water. Some of them will be reacts with the water. So that we can see with the help of chemical reactions, equations. So the reaction of a metal with water. So the metal forms respectively hydroxide and hydrogen gas when reacts with water. So metal plus water gives metal hydroxide plus hydrogen. So most of the metals do not react with water. However, the alkaline metal reacts vigorously with water. So first, that is reaction of sodium metal with water. Sodium metal forms sodium hydroxide and liberate hydrogen gas along with a lot of heat when reacts with water. So when sodium reacts with water, what happens? The sodium hydroxide will be formed and there will be the liberation of hydrogens with a lot of heat. So equation Na plus H2O gives NaOH, that is sodium hydroxide plus hydrogen gas. Next, the reaction of calcium metal with water. So the calcium forms calcium hydroxide along with the hydrogen gas and heat when reacts with the water. So here also the heat will be liberated. So calcium plus 2H2O gives calcium hydroxide, that is CaOH twice plus H2 hydrogen gas will be liberated. Next, the reaction of magnesium metal with water. So magnesium metal reacts with water slowly and forms magnesium hydroxide and hydrogen gas. So the magnesiums will not react very fast. It reacts with water very slowly. So the magnesium plus H2O gives magnesium hydroxide, that is MgOH twice plus H2. When the stream is passed over the magnesium metal, the magnesium oxide and hydrogen gas are formed. So when magnesium stream will be passed over the magnesium metal, what will form? The magnesium oxide will form instead of magnesium hydroxide. So magnesium plus water, this is in the form of stream. So it will form a magnesium oxide plus hydrogen gas. Next, the reactions of aluminum metal with water. The reaction of aluminum metal with cold water is too slow to come into notice. So aluminum will not react with the cold water. It is very slow. So when the stream is passed over the aluminum metal, the aluminum oxide and hydrogen gas are produced. Here it is also same. So when when the metal reacts with the cold water, it will form magnesium oxide. When it reacts with a stream, you will get an aluminum oxide. So that is Al plus 3H2O. You will get Al2O3 plus 2H2O. So you have seen already, that is what happens when metal reacts with water. It produces metal oxide and hydrogen gas. When it will be soluble in the water, then it will form what? Metal hydroxide. Okay. So same this you can see here. Magnesium. So in this what happens? The magnesium oxide, that is a magnesium is not dissolved in the water. So it will form only the magnesium oxide. Here it is also aluminum oxide will be formed. Next, the reaction of zinc metal with water. The zinc metal produces zinc oxide and hydrogen gas when the stream is passed over. The zinc does not react with cold water. Here the zinc does not react, so the reactions will be take place using a stream. So the Zn plus H2O gives ZnO, that is zinc oxide plus H2. Next, the reaction of iron with a metal. The reaction of iron with cold water is very slow and come into notice after a long time. So the iron forms a rust, that is iron oxide, when the reacts with the moisture present in the atmosphere. So the iron oxide and hydrogen gas are formed by passing in a stream over iron metal. So iron Fe3 plus H2O gives Fe3O4 plus 4H2. So here it is also what happens, the iron does not react with cold water. So when it will be, means slowly it will react, but when it will be after long time, but when it will be come in contact with the moisture present in the atmosphere, so it will form what? Rusting, that you know. So the rusting is nothing but it is an iron oxide. Both calcium and magnesium are heavier than water, so but still float over it. Both calcium and magnesium float over the water surface because a hydrogen gas is evolved when this metal reacts with water. So it is in the form of bubble which stick on the metal surface, so therefore they float over it. So here what happens, the calcium and magnesium, they are heavier metal. So what happens, they will be float. So you can see that is calcium when reacts with water, it will give calcium hydroxide plus hydrogen gas. So the other metal usually do not react with the water or reacts very slowly. That is lead, copper, silver, gold do not react with a stream also. So thus the order of reactivity of the different metals towards the water may be written as potassium, sodium, then calcium, magnesium, aluminium, zinc, ferrous, lead, copper, silver, and next we will see that what happens when the metal reacts with an acid. So you have already learned that the metal reacts with acid, it gives salt and hydrogen gas. So the metal plus dilute acid gives a salt plus hydrogen gas. So but do all the metal reacts in the same manner? So we can check with an activity. So that is activity 3.11. Collect all the metal sample except sodium, potassium. So if the samples are tarnished, rub them clean with a sandpaper. So first we are taking in a metal, and then first we have to clean them with a sandpaper to remove the dust. Here why we are not taking in a sodium and potassium, because they are rigorously reacts with a cold water, so that we are not taking sodium and potassium. Put the sample separately in the test tube containing dilute hydrochloric acid. suspended the thermometer in the test tube so that their bulbs are dipped in the acid. Observe the rate of formation of bubbles carefully. So which metal reacts vigorously with an hydrochloric acid? Which metal did not with which metal did you record the highest temperature? Arrange the metal in the decreasing order of reactivity with dilute acid. Then write the equation for the reaction of magnesium, aluminum, zinc, iron with a dilute hydrochloric acid. So in this uh, activity, we are taking a sample and we are taking the sample in the test tube and we are adding a dilute hydrochloric acid to this one, and we are suspended thermometer so that what happens, it bulb will dip in the acid to check the rate of formation of bubbles carefully. So here we are then checking that which metals reacts vigorously with an hydrochloric acid, and you have to record the highest temperature. Then you have to arrange the metal in the decreasing order of their reactivity with a dilute hydrochloric acid. So first, the reaction of metal with a dilute acid. So the metal form salt with when reacting with a dilute acid. So metal plus dilute acid gives metal salt plus hydrogen. First one, we are seeing that reaction of sodium metal with a dilute hydrochloric acid. Sodium metal gives a sodium chloride and hydrogen gas when reacts with a dilute hydrochloric acid. So Na plus HCl gives NaCl plus H2. Next, the reaction of magnesium metal with a dilute hydrochloric acid. So the magnesium chloride and hydrogen gas are formed when magnesium reacts with a hydrochloric acid. So Mg plus HCl gives MgCl2 plus H2. Next, the reaction of zinc with a dilute sulphuric acid. So the zinc sulphate and the hydrogen gas are formed when the zinc reacts with a dilute sulphuric acid. So this method is used in the laboratory to produce a hydrogen gas. So Zn plus H2SO4 gives ZnSO4 plus H2. So the hydrogen gas is not evolved when the metal is treated with a nitric acid. Why? Because here, the nitric acid is a strong oxidizing agent and it oxidizes the hydrogen gas liberated in the water and itself get reduced to the some oxide of nitrogen like nitrous oxide, that is N2O3, and nitric oxide NO, and nitrogen dioxide, that is NO2. So some oxide of nitrogen like nitrous oxide. So first the formula of N2O is given. So first is wrong. So this is a correct, that is N2O, and nitric oxide, that NO, and nitrogen dioxide, that is NO2. So the copper, gold, silver are known as a noble metal. These do not react with water or dilute acid. But the magnesium and manganese reacts with dilute nitric acid to evolve hydrogen. So, you must have observed from the activity 3.11 the rate of formation of bubbles were faster in the case of magnesium. So, the reaction was also the most exothermic in this case. So, the reactive decreases in the order of magnesium, aluminum, zinc and ferrous. So, in the cases of copper, no bubbles were seen and the temperature also remained unchanged. This shows that the copper does not react with a dilute hydrochloric acid. So the order of reactivity of the metal towards dilute hydrochloric acid and sulphuric acid is in the order potassium, sodium, calcium, magnesium, aluminium, zinc, ferrous, copper, mercury and Ag. Aqua region. So what is aqua region? So aqua region from latrine, from royal water. So in latrine we are saying it is royal water. It is a freshly prepared mixture of concentrated hydrochloric acid and concentrated nitric acid in the ratio of 3:1. So we are taking an hydrochloric acid in the 3 part and then a nitric acid in the 1 part. When these are mixed, you will get an aqua region. It can dissolve gold even, though the either of this acid can do so alone. So aqua region is highly corrosive, foaming liquid. It is one of the few regions that it is able to dissolve gold and platinum. So this is the diagram of an picture of an aqua region. So and here what happens, you can see that is a gold recover from an aqua region, that is the gold will be dissolved and we are taking gold from this aqua region, so it is in a powder form. So hope you all are understood this one. Thank you. We will meet in the next part of this chapter.